Greetings. My name is Leonardo Gonzalez,
My name is Ryan Medina Velasquez.
and with guidance from Professor Guillermo Serrano, we are conducting the Autonomous Bow Undergraduate Research Project. The main goal of this project is to recreate an autonomous boat capable of traveling through water bodies with minimal human assistance or interaction. The meaning of designing an autonomous boat system is because of the amount of problems it could potentially solve. An automated system is far more precise and accurate than human pilot navigation. It is more cost effective at long terms since it doesn't require a crew. Therefore, it also reduces drastically human effort. It can accomplish surveillance, transport, or rescue tasks. In this presentation, we are going to describe the steps to accomplish this goal. For this project to be possible, we need some core equipment that can work together to deliver the desired outcome. This is a short list of the most important components, which we'll talk later in detail in this presentation. These parts and equipments were researched and chosen carefully for the goal of the project. For the main program that will be running in the system is the navigation program called Carrot Chasing Algorithm. The program, combined with the GPS and the data logger inputs, will be capable of directing towards a desired point. The way it works is that the program is going to generate a carrot for the vehicle to follow throughout the path. This way, if the vehicle steers away from the path, it can recalculate itself towards it until it reaches the endpoint. Here on the left is a simple diagram of how the boat takes into account many trigonometrical parameters and formulas to generate the carrot. On the right, we have a MATLAB simulation of the program based on some random initial parameters. You can see how it steers towards the path even though the starting point is far away from it. This program will serve as the brain of the operation that will work with the main circuit components.
Circuit design, assembly, and testing. Um, First, we have the eyes of the autonomous system, in which is the GPS 16X HVS that will let us know the geographical coordinates of the boat at all times, and a QKAS08 heading sensor. What's special about this sensor is that it will be complementing the GPS since it provides a 3-axis compass and attitude sensor, basically give us additional data that the car chasing program can use for it to be able to turn and adjust thrust. Uh, all of this information that is picked up by both both sensors, it will be sent to the CR300 data logger, in which we'll be storing all of this data and executing the car chasing algorithm. On the next slide, we have a Robotech QSBL23 microcontroller. This microcontroller will give the instructions for the motor control. And these motors are the T200 thrusters that will be capable of giving that mechanical force for propulsion on water. Then we have power. So the power is gonna be a GVB 8WP solar panels that will provide the energy of the whole system in an eco-friendly, reliable, and efficiently manner. This will make the boat more self-sustained, so it has very little to no human interaction. And from where is this energy coming from? How is it going to be picked up? Well, we have the semi-flexible solar panel. It's a grade A PERC monocrystalline solar cells, with much higher efficiency and more durability than other monosolar cells.
Here is the first prototype of the boat. It's made of Formula 250 foam for the base and EPS foam to support the solar panels and electric components. That way, it provides isolation from the water. It's a catamaran type of boat because it provides great stability while having a lot of space.
Prototype testing. Data corroboration phase. In this phase, we verified that the data obtained by the sensor is correct and accurate, since this data is going to be processed by the cache chasing algorithm, and we need to be for it to be precise. The communication phase is the communication between the CI300 and the Robotech SB23. They each connect with PWM, and the Robotech adjusts the thrust movement, in which will give the mechanical propulsion of the boat. So we need that communication to be exact, since the information obtained from the carrier chasing algorithm is going to be reflected in the thrusters. In the implementation phase, we will take the communication phase and the data corroboration phase and integrate all of it into the boat, in which it will be tested and see the performance. Project schedule. At the beginning of this investigation, we decided to set up some milestones in able to see our progress during this academic year. We began on August, and from August to September, we were on the compilation of information phase, which was mostly research, theoretical thinking, and how we were going to overcome certain problems that we may encounter. From September to December, the data corroboration phase, which is present. We have the coding necessary for receiving data from the sensors for the corroboration, and we have the carrier chasing algorithm with simulations as seen in past slides. In 2022, we have from January to March, we will be in the communication phase, and from March 2022 to May 2022, we will be at the end of our goal, in which is the implementation phase, and we organized all our milestones and apply it